Hey, what's up? It's Mr. Skis. I am going to do a practice version of the quiz, the calculator quiz, in this video. And I'm going to walk through each of the calculator commands. Let's go ahead and do it. So I have a version of the quiz here. And well, the first thing is I probably want to store all these functions because as you know where this quiz is going, we're just answering a whole bunch of questions about them. So I'm going to store them. So here's this question, the 0.2, or this function, 0.2x cubed plus 0.4x squared, etc., etc. And I'm going to type it in exactly as we see it there. So I'm going to go ahead and switch to the calculator. Um, I'll link this document in the description of the video if you'd like to pull it up on your own, because it's a little difficult to do both at the same time. So let's get into it. I'm going to go down and choose calculator here. So I'm just hitting the arrow keys down and hitting enter on calculator. And I'm going to type the function. Like I said, I'm going to link this document. You can't see what I'm typing, or you can see what I'm typing, but you don't see the document in front of you unless you pull it up. So I'm typing exactly what I see, 0.4x squared. So squared is right here beside the number 4. And then minus 3.5625 plus 1.6875. And before you commit to storing, I would always just do a double check to make sure that you typed in everything correctly. 35625. Yeah. So how do I store this? Above var in blue is store, STO. So I can hit control and then var, and we'll bring up that arrow. And this is the f of x function. Okay. Hit enter and done. The next function is g. Again, I will link this document if you'd like to print it out and follow along. I have a minor mistake in my document. I made this a little hastily. I accidentally have that like times or asterisk symbol there. It's just supposed to be plus. But I will continue here. So this one involves a lot of fractions. So I can show you where a fraction is. So we've got 3x to the fourth. To do the fourth power, you of course just hit caret. It creates the exponent to the fourth. Make sure to remove your cursor from the exponent, right? Because you got to continue typing the rest of the function. So hit the arrow over key. And then minus the first fraction is 81/4. So beside the number 9 is this button here. And it will open this up, and you can use your arrow keys to navigate as always, and then press enter on the fraction. And 81, go down to the denominator, fourths. And then make sure to move your cursor to beside the fraction, and you can type x cubed, the caret symbol there to do cubed. Again, always removing your cursor from the exponent, plus the next fraction, again fraction. All right, sorry about that. My mic cut out. So where was I? If you ever get lost, like where was I right now? I just fiddled with my mic on my headset, and now I'm back. I'm like, where did I leave off? You can always hit escape, and you can just sort of reset yourself here. So I was trying to type 733 over 16. So fraction, hit enter on that, 733 over 16 times x squared. This is like the longest part, right? Minus the next fraction is 2531 over 64, and that's x squared. And the last, oh no, just x, not x squared, sorry. Just x. And then plus fraction beside the number 9 there. Open that up, 645 over 64. Again, just do a little double check before you go and store it, because you really don't want to have to type it again. Just do a little double check. And we're golden. So store again is in blue above var. So you hit control first and then var, and it brings up that arrow. And we can store this as g. Those were the two longest functions to type. The next two are pretty simple. So we have a logarithm. log is over here above 10 to the x in blue, or it's also in the same menu where fraction was. So it's up to you. You can open this up and then scroll over, or not scroll, but click with the arrow keys over to the log and then hit enter. Or I could delete that, and I could have just done control and then 10 to the x will bring up the same thing. So, if you forget where it's at, you can find it in multiple locations. So log base 7 of x minus 8, and then make sure to move the cursor outside of the parentheses to type the minus 2. Do a little once over. Yep, it's fine. Control var to store, and we're naming this as h of x. And the last function involves e. I said it in every class period, and I'll say it again right now. There's a difference between e in the alphabet keys versus e over here in the 1, 2, 3 row. Okay, so you want to use e over here on the same row as 1, 2, 3. So e to the raise to the power of 2x minus 18, and then remove the cursor out of the exponent, and then minus 5.75, and do a little once over. Beautiful. Control var to store, and we're going to store that as j of x. And now we actually get to the math. So that's got to be the longest part. The first question, I'll switch. The first question says, at what value or values of x does f of x have a relative maximum? So we need to graph to see the maximums of f. So I'm going to hit the home key, and I'm going to arrow over to the graph and hit enter, and I'm going to plot f of x. When you pull this up, you can't see the maximum. It is going beyond the window of the graph. So we need to adjust the window. So we can do that in menu, and then 4 is window zoom, so choose the number 4. In 1 is window settings, so choose the number 1, and you can adjust this. The negative 10 to 10 is fine. It's the height that needs to change. So maybe, so arrow down and highlight the y maximum, and maybe let's make it 15 and hope that that's good enough. Perfect. If you chose 10 and that wasn't good enough, then you're going to have to do it again. But, choose a decently large number in hopes that you'll catch it, and there we can see the maximum. So now we need to find it. So menu, analyze graph is 6, and maximum is 3. And then, you use the little pad right here to drag as the mouse to move it left or right, or you could use the arrow keys to move it left and right. In the end, though, you press enter when you're done with the lower bound. Move this to the right, and you can see how it finds the maximum there. Hit enter, and it finds the maximum. Now, I have just opened this calculator on my computer, and you can see the setting isn't quite right. Everything's rounded too short. So I need to go to menu, 9 for settings, and change that float 3. Go ahead and hit open up this menu here and change this to probably float 6. So now I can see more digits. So now I'm going to go ahead and write that the maximum occurred at x equals negative 3.193. Everything gets rounded to the thousandth place. So the 9 after the 2 is rounding that up to a 3, if you can read that. Hopefully that's legible enough for you. So switching to my document, that's all I wrote. That's where the maximum is. So now question 2 is asking about g. At what values of x does g of x have a relative minimum? So going back to my calculator, I'd rather plot g on a different page. So I'm going to press home, and then I'm still on graph, so I'm going to hit enter, and you can see up here at the top there are new tabs, and it opened up a new tab for a new graph, and I can type g of x, the g of x function that we stored. And voila. If you find things sensitive, go ahead and zoom in on this if you would like to get rid of some of this empty space. So that's exactly what I'm going to do. I'm going to change my window from 0 to, let's say, 1, 2, 3, 4, 0 to 5. So menu, 4 for window zoom, 1 for window settings, 0 to 5. Now, if you're watching this video and I do anything a little too fast, you have the luxury to rewind. I'm trying to take my time here, and if I've said something before, I'll probably say it a little bit quicker. For example, right there with the window settings, I didn't dwell on that as much. So now we do minimum. So menu, and there's two minimums that we can see there on the graph, 6 for analyze, 2 for minimum, and we're going to use this command twice. So go ahead and drag this dotted line to the left of the first minimum, hit enter or confirm or whatever, and drag it to the right of that minimum, and it clicks into place. So the first minimum is at x equals 0.747, and then you'll have to do it again. So menu, 6 for analyze, 2 for minimum. Again, however you feel fit to drag this, you can use the arrow keys if you'd like to move it, but just make sure you put it a little to the left, hit enter, and move it to the right, hit enter, and you've got this here. You got your other minimum. The other x value occurred at 2.652. The 8 after the 1 rounded that up to a 2. So at 2.652. So that's the two x values. And I'll show you on my screen. I recorded the two x values when those minimums occurred. Okay. On what intervals of x is g of x concave up? So if I go to my graph here, well, we can see when the concavity is changing. It's going from concave up to concave down to concave up. And it asked, when is this thing concave up? If I maybe go like this, maybe I can blow this up a little bit more for you. You can see that the inflection is occurring here and here. So maybe I can drag this to make this a little bit bigger. Maybe this is good for you. So I'm going to do inflection. So menu, 6 for menu, 6 for analyze, and then 5 for inflection. And again, you can just use the arrow keys if you'd like, or whichever you feel fit, but go ahead and drop that dotted line to the left roughly of the point of inflection, hit enter, and then move it to the right, and it will identify your point of inflection. So it starts out concave up. So what is the beginning of this interval? Negative infinity. It doesn't, this interval doesn't end as we go to the left. It is concave up forever. So it's concave up from negative infinity, but the concavity does stop over on the right-hand side at 1.137. So my interval of concave up is negative infinity up to 1.137. And I'll show you my screen. It's like this. That's your interval. Because concavity doesn't happen at a specific spot. Concavity happens over an entire interval, unlike minimums and maximums that do have a specific spot. Sorry, I just got cut off again because my headphones have a setting apparently to turn off if no sound is coming through them. So they're like turning off after 10 minutes, which is annoying, but I'll figure it out. So where's the next point of inflection? We say menu, 6 for analyze, and 5 for inflection. And again, however you want to put this dotted line there, go ahead and leave it somewhere, and then press enter to confirm your location, and then drag it to the right and press enter to confirm your location, and it finds your other point of inflection. Okay. Now, if you ever have anything overlapping like this, it's a little difficult for me to show on the computer, but you should put the cursor above the number. And then what's difficult for me to do is, how do I keep my cursor above the number and simultaneously move the cursor over here to hit control? I can't, but you can, right? Because you can just press control. So you can do something I can't do right now. You're going to hover your hand over this, press control, and then press the center button. And when I say the center button, I mean the center of the D-pad. You see how it has a little pinch icon? Control, and then the center button pinches. You see on the screen is like a hand grabbing. Something like that should happen for you, okay? And you should be able to pinch the number and move it so you can see it a little bit better. So control and the center of the D-pad will pinch and grab, okay? So the next interval begins at 2.238 and continues on until infinity. So I'll go ahead and write that down, 2.238, and it continues on until infinity. So there's that. So there's the two intervals of concave up. The next question is about f and says on what intervals of x is f concave down? So if you want to change back to the 1.2 tab, if you see around the D-pad in blue, this has a little arrow on this. This means page over to the left, and this means page over to the right. So if you hit Control and the left arrow key, you will move a page back to the left, okay? So now that we're looking at f, where is f concave down? Well, it starts out concave down over on the left-hand side at negative infinity, all the way up until, well, where's the point of inflection? We do it again. I'll do this a little quicker. Menu, 6 analyze, 5 inflection, a little to the left, a little to the right, and look at that. So on what intervals is f concave down? From negative infinity all the way up until negative 0.667. Negative 0.667. I'll show you my answer. Oops, forgot the parenthesis. That is where it's concave down. Now we're transitioning to talking about h. Find the average rate of change of h on the interval 10 to 12. So as you recall, f of b minus f of a all over b minus a is average rate of change. So in the context of this problem, what are we doing? H of 12 minus h of 10 all over 12 minus 10, because this is our a and this is our b. So we just quite literally need to punch this into the calculator and see what it equals. So if I go back, if you'd like to create a new calculator page, you could do that. Or if you would just like to tab back over to where we started this, you could hit Control and then the left arrow key to go a page over. And now we're looking at where we were typing earlier in the video. And we can do a fraction and do the average rate of change. So beside the number 9, you can open this up and go back over to the fraction. And we can do h of 12 minus h of 10, go down to the denominator, over 12 minus 10. If it comes out in a nice pretty answer like this, as you know, we hit Control and Enter above that, right? By hitting Control, that means we're doing the blue thing, and the blue thing is the squiggly approximate symbol. So Control Enter means approximate, and it comes out 0.178. And so I just wrote that down. I wrote that it equals 0.178, average rate of change. So now we find the values of x for which j of x equals 10.2. In the context of this problem, we're really just solving. We're solving for when j of x equals 2. What does x need to equal in order for j of x to be 10.2? That's the question. So we can solve that. I use air quotes because there's the solve command. So if we go back to the calculator, we can do menu, 3 for algebra, and 1 for solve. And we're setting j of x, our function, equals up here in the same row as 789, equal to 10.2. And the other thing that we have to do with solve is tell it what to solve for, and it needs to solve for x. So we say comma x, and we hit enter. And it tells us our answer. 10.38. The 4, 7. The 7 would round that 4 up to a 5. So x equals 10.385. The other thing to remember here is I'm going to go to home and open up a new graph. The other thing to remember here is that if you plot j of x, there it is. And if you plot the line, remember if you double click anywhere on the screen, it'll open this up. And if you plot 10.2, I can't see 10.2 at the moment because my window isn't large enough. And notice our function is going off to the right as well. So I'm going to adjust my window settings, menu, 4 for window zoom, 1 for window settings, and I'm going to change this from like 0 to, I don't know, 15, and then change my max to, I don't know, 15 as well. There we go. So by solving j of x equal to 10.2, you're also simply finding where it's intersecting 10.2. So if we do menu, 6, analyze graph, 4, intersection, and we go a little to the left and a little to the right, look at that number, 10.3847. That's the same number. So if I control left arrow to tab back over, this solving is the same as finding the intersection. So just keep that in mind, especially if you're struggling with the solve feature for whatever personal reason. Okay? And speaking of graphing j, the next question says to find the points of intersection of j and h. I don't know if I showed my screen. All I did was write down 10.385. Find the intersection of j and h. So I've already plotted j, correct? I've already plotted j. But if you didn't do that little side thing with me, let me start over. I'm going to open a new graph, and let's plot j and h. So you plot j of x. Like I said, when you have this default window, it sort of goes off screen, so we're going to need to adjust that. And then if you double click somewhere in the center of the page, it'll bring this up, and you can type h of x. And it turns out both intersections do squeak their way into the window, but it still might be nice to adjust that just so the numbers have room to actually show themselves. So I'm going to adjust this window to 1, 2, 3, 4, 5, 6. I'm going to adjust my window from 7 to like maybe 12. Okay? So menu, 4 window zoom, 1 window settings, and I'm going to do 7 to 12. And hit enter. Now fills the screen here, and my 2 intersection points are much more obvious. So menu, 6 analyze, 4 intersection, and I'm going to go a little to the left and a little to the right, and there's 1 point of intersection, and do it again. Menu, 6 for, and I'm going to do 6 for analyze and 4 for intersection. Drop it a little to the left, a little to the right. So the question does say find the points of intersection. So I do want you to list the entire point. So that would be 9.69, the 8 would round the 5 up to a 6, comma, negative 1.729. The 5 would round that 8 up to a 9. And then the other point down on the bottom part of my calculator screen, 8.00, the 8 would round that 0 up to a 1, comma, negative 5.614. So I wrote both coordinates down this time. I'll show you my screen. I have both coordinates written. Find the points as opposed to find the value of x. You know, if you see the distinction of how I'm asking for that. And then it says to find the zeros of j of x. Okay, find the zeros of j of x. So if I go back to my graph, now I could plot j again, or I could find the zeros on this same page. I'll show you both. Okay, so the 0 is happening right here when j is crossing the x-axis. So if I do menu, 6 for, if I do menu, 6 for analyze, and 1 for 0, it's going to ask me which graph would I like to find the 0 of. So you're going to need to move the cursor and highlight or click on the J graph. And then it prompts you to do a little to the left, a little to the right, and it finds the 0 at 9.87. The 6 would round that 4 up to a 5. Now, if you plotted J again, you went home and went to the graph and plotted J again, then it wouldn't prompt you to do that. And also the 0 is essentially off the page. So you would need to adjust the window again, which is a little annoying. And then when you do menu 6 for analyze, 1 for 0, it won't prompt you to choose which graph. It'll just have you go a little to the left, a little to the right. But I'll show you my answer there. I just said find the 0. That's the 0, 9.875. 2 more to go. Find H inverse of a half. Well, if we're trying to figure out what this equals, right? I'll write X like I usually do in class. If we're trying to figure out what this equals, this could be instead written like this, right? If you want to know what H inverse of a half is, that's the same thing as asking when is H of X equal to a half? And this is the same question as this, right? That's literally the same thing. It's just now talking about H. So let's use the solve feature again. I'll go back to the calculator, and if you recall, 1.1 is the tab where all my calculations have been happening, but it's kind of multiple tabs over at this point, right? So if I do Control and then up, it will show me all of the windows. Now, they're kind of pixelated, but if you know what you're going for, which is the very first one, just go up to that, hit enter, and you can go back to where we were. And also, if you come up here and hit enter on something we've previously typed, it will copy it into your situation here, right? So if you kind of want to just quote copy it, you can then copy it and then move this over and change this to an H instead of a J. I mean, you could just retype the whole thing, but I'm just demonstrating something that I haven't demonstrated before, and then set this equal to 1/2 or 0.5. Hit enter, and it gives you your solution, 137.642. And if you notice here, having float 6, right? Look at this. Because the answer was so large, there were only 3 digits here. Some of you might go, why do we have float 6? It's always I never need all these digits. Well, look here. Float 6 makes a triple digit number rounded to the thousands place perfectly. If we had float 5, it would have cut off the 2. That's why I like float 6. It accounts for those potential triple digit numbers. All right. So to conclude, I'll show you my answer, 137.642. To conclude, we want to find the vertical asymptotes. I'll show you. Find the vertical asymptotes of f over g. Find the vertical asymptotes of f over g. Well, if we go to the graph, let's open up a new graph and let's just plot f over g. Let's just get a vibe of what f over g looks like. We're going to have to find the asymptotes like a more methodical way, but we can still plot it and, like I said, get a vibe. So if I do f over x, or f of x over g of x, and go ahead and plot this, we can see there are 1, 2, 3 vertical asymptotes. Now, where are the asymptotes? Well, we can analyze the zeros of each of the functions. So this is the most mathematically involved problem. We have to set the numerator equal to 0. We have to set the denominator equal to 0. Any zeros in common means a whole. And then everything else is going to be, well, I should use my words carefully. Any of the other zeros from the denominator will create an asymptote. Okay? So any zeros in common creates a whole, and the other zeros from the denominator create an asymptote. So I hope you can, if I zoom in here, let's zoom in and go from like 0 to 1, 2, 3, 4, 0 to 5. Menu, window, settings, 0 to 5. You can see that the asymptote, one is happening at like 2 point something. One is happening, that's not 2, that's, what is this counting by? I don't know what this is counting by. I wish that was more obvious. That's kind of annoying. Yeah, I can't tell what that's counting by. But the point is we have three asymptotes here, here, and here. So let's figure out where they are by doing what I was just saying. So I'm going to do Control and left arrow to go back over here. So I'm going to menu, 3 algebra, 1 solve, and I'm going to set f of x equal to 0. And then, remember what I said, you can just copy by going up, highlighting that, and hitting enter on that. And then I'm going to change that f to a g. Don't like that. Don't like that it's not showing the answers as a decimal, so control enter. So now you can see what they do and don't have in common. So look at that. They have a 3 in common. Oh, you can't see my screen. Oh no, I've been talking with... So I'll go back and show you that f over g graph. F over g had 3 asymptotes. And we're trying to figure out where they are. You saw me write the things on the iPad. So I'll do this again because you didn't see me type any of it. Menu, algebra, 1 for solve. I set f of x equal to 0. Equal to 0. And then I just hit the arrow up keys and highlighted this so I could copy it, hit enter on that, and then backspace this to a G. Control enter on this to get the decimals. And you can see that they have a 0. Oh, it's behind my head. Here, let me type a few things. See, there we go. So you can see that they have a 0 in common. So that's a whole. Which one of these things was the denominator? F or G? G was the denominator. So these 3 other numbers are the vertical asymptotes. So this is a vertical asymptote at x equals 0.434, x equals 1.25, and x equals 2.067. These 3 other numbers from the denominator, the 3 other zeros from the denominator are the vertical asymptotes. So if you go back and look at our graph, this is the 0.4. It's a little hard to tell. Here, I'll demonstrate. Menu, 5 for trace, 1 for graph trace, if I move along this, take a look at the numbers on the bottom. You see the, oh, it's behind my head. I can't move my head. Sorry, guys. Well, you see this number right here that says 2.2? That's the x value. So as I go further to the left, I'm getting closer and closer to the asymptote, right? And look at that. It's getting closer and closer to, right, to the 2.0 number that I wrote down from this page, right? 2.06. Okay? You understand? That hopefully you can tell how that's lining up. And then if I continue tracing, it's hitting that maximum here. We don't really care. But where's the next asymptote? 1.25. So you can see how this, look at that. It actually found the number, that time. That's interesting. It didn't show us that for the other one, but 1.25 clicked in. That's interesting. And then if we keep tracing to find the final asymptote, we're getting closer to that last number is 0.434. And you can see, look at how it skips over it though. But you can understand how it's right there in between. Okay? So the zeros from the denominator that don't match are giving us our vertical asymptotes. And again, there's my final answer. All right. Apologize there for the little hiccup at the very end, but I think that was a pretty good video, and I think I went at a pretty good pace, and I hope you appreciated this, and I hope you feel that much more confident with your calculator. Cheers. And I'll catch you in the next one. Peace out.